If we want to build a skyscraper or construct a habitat on the moon, we rely on a strictly brute force logic. We manufacture incredibly heavy materials in a factory, transport those materials over massive distances, and use large machines to stack them into place. Biological systems operate under completely different constraints. A termite mound is a climate-controlled architectural structure that can reach several meters in height. The insects do not import their building supplies. They extract soil from their immediate environment, process it, and deposit it. We see the same scaling principle underwater. A massive coral reef is entirely constructed from calcium extracted directly from the surrounding seawater, deposited over time by billions of tiny polyps. The organisms building these massive structures do not possess a top-down architectural blueprint. They are reacting blindly to local chemical signals in their environment. A termite deposits soil when a pheromone tells it to. This biological mechanism is the foundation for a proposed engineering framework known as directed consumption architecture. The proposition outlines a complete replacement of the biological components. We swap the biological signaling hormones for an artificial intelligence brain. Then we replace the living organisms with trillions of synthetic, virus-like machines that operate at the nanoscale. If we can successfully translate digital commands into physical chemical signals, we bypass the need for factories and cranes entirely. We could autonomously grow entire cities directly out of raw dirt. The directed consumption architecture framework splits this massive task across 5 distinct layers. Layer 1 is simply the human operator. You don't need a background in chemistry or engineering. You only need to provide a natural language prompt, like asking the system to build a load-bearing dome. That prompt passes down to Layer 2, the LLM brain. The AI here does not control physical robots with motors and servos. Instead, it translates text into a 3D topographical map made of precise chemical signals. Layer 3 brings us into the physical world. The macro device, a highly calibrated chemical printer, reads the AI's math and oozes exact chemical concentration gradients directly into the soil. But the macro device does not print nanomachines directly. It operates on Layer 4, called cascade fabrication. Similar to how the semiconductor industry uses large tools to print progressively smaller generations of microchips, the macro device prints the first generation of microscopic fabricators, which then print the final nanoscale workers. To make sure the final physical structure matches your prompt, the LLM maintains strict libraries. It maps the specific mathematical geometry of the walls, cross-references that against the structural materials available in the local dirt, and calculates exactly which chemical signals will trigger the correct reactions. All of the intelligence in this system is trapped at these top layers. The entire process relies entirely on creating a highly specific chemical environment that forces an inevitable physical reaction at the bottom. That brings us to Layer 5, the atomic scale, and the functional worker of the system known as the synthetic Nano Instance. Viruses provide the exact blueprint for these instances. A virus has no metabolism of its own and is generally not considered alive. It floats perfectly inert until a specific molecular signal locks into its surface receptor, which triggers its activation. Once activated, the Nano Instance follows exactly 2 rules. Rule 1 is consume. The instance absorbs ambient energy and physically converts the locally available soil into structural elements, like glass or the chemical equivalent of concrete. Rule 2 is replicate. It does this through a process called replication cleavage geometry. The instance reaches a specific size and dissolves, releasing stored energy to form exactly 2 brand new instances from local molecules. The crucial twist is that these new instances form exclusively in the direction of the AI-generated chemical signal gradient. Because existence requires continuous energy and chemical cues, the system has an absolute built-in safety protocol. If the AI cuts the signal or ambient energy drops, the instances stop replicating. The default state is immediate structural collapse and total termination. There is zero intelligence at the worker level. Every piece of complex architecture produced by this system is born entirely from the relentless, mathematically directed repetition of blind consumption and division. This process is known as emergent construction. The individual instances have no idea they are building a wall or a dome. They simply climb the invisible hills of a chemical gradient, and massive physical structures emerge as a byproduct of their replication. If the human operator asks for an architectural feature, like a door or a hollow interior, The AI simply creates a signal absence zone. The chemical gradient drops to 0 in that space, replication halts entirely, and a perfectly empty window remains. While this framework reads like science fiction, it relies entirely on physical components that have already been independently verified in peer-reviewed laboratories. Synthetic chemists have already demonstrated out-of-equilibrium self-replication. Biologists have created cell-free environments, like the PURE system, which allows protein synthesis without living host cells. And robotics companies have already proven that LLMs can accurately control physical systems. The remaining engineering challenge is simply integrating these existing components. Because the system is designed to consume whatever is locally present, its most critical application lies beyond Earth. Martian regolith, the loose layer of dusty, rocky material covering the planet, is incredibly rich in iron oxide and silicates. The swarm could process this dead rock into life-sustaining atmospheric habitats. The limits of human expansion into the solar system will not be defined by the weight of the steel and concrete we can load onto a rocket. They will be defined by our ability to whisper instructions to the dirt and watch our civilization grow from the ground up.